Today we're going to graph lines from both slope-intercept form and standard form. First, we're going to look at slope-intercept form. Your slope-intercept form is y equals mx plus b. M, the number in front of x, is your slope. That's going to tell you how to move. B, the number alone, is your y-intercept. Y-intercept means where your line crosses the y-axis. That's also where we're going to begin. So, the first thing you need to be able to do is say what the slope is and what the y-intercept is. So first, looking at our first example, y equals negative 2x plus 4. My slope is the number in front of x, so in this case, my slope is negative 2. The y-intercept is the number alone, which would be 4. For the next one, I have y equals 3 minus 1/2 x. So the number in front of x is negative 1/2. That is my slope. The number alone is my y-intercept. That's my b. Remember, slope is represented with an m. Y-intercept is represented with a b. On the next example, I have y equals 2/3 x. So the number in front of x is my slope, that's my m. On this one, it's 2/3. Since I have nothing written extra, nothing being added or subtracted, that is the same thing as adding 0 to my x. So if there's nothing written, that means you're going to start at the origin. In other words, your y-intercept is 0. My next example, y equals 1. This means that your x has been canceled out with a 0. Since there's no x, this means our slope is 0. And then our y-intercept, the number alone, would be 1. I guess I should change that to red to match my others. And then finally, x equals 2. When you have x equals, this is the one that's unlike all of the others. X equals 2 is a vertical line, which means our slope is undefined. It's different from all the others. And then x equals 2 will never cross the y-axis. So for this one, we actually don't have a y-intercept, so we write none. If you need a refresher on slope, I would pause this video and go back and watch my slope video before you begin this one. Our slope lesson is what we did in the last class. Now, the first line that we're going to graph is called our linear parent functions. Just like you come from your parents, every function that we talk about in math comes from its parent function. Linear means it's going to make a line, so our linear parent function is y equals x. Before we begin, let's determine the slope and the y-intercept of y equals x. For y equals x, there is an imaginary 1 in front of the x that we do not write. There's also an imaginary plus 0 here. So my y-intercept is 0. My slope is 1. Let's talk about how to graph that. You're always going to start with your y-intercept, and y-intercept means where it crosses the y-axis. So my first step is to plot where b is 0. b is 0 means that y equals 0, so I am starting at the origin 0, 0. From here, I'm going to apply my slope, and from our last lesson, we learned that slope is rise over run. Now, if my slope is 1, that is the same thing as 1 over 1, so I'm going to rise 1, run 1, all the way across, which means I'm going to go up 1, right 1, all the way across. I go, yes, up one, right one, up one, right one, all the way to the edge of my graph. You want your line to fill your whole graph. Now, if I want to continue it in the other direction, then to keep my slope positive, I would go down one, left one, down one, left one, all the way across. So this right here is the graph for our linear parent function y equals x. Moving on to our next example, we have y equals 2/3 x minus 4. So for this one, the number in front of x is 2/3, that's my slope. My y-intercept is -4. We're always going to start with our y-intercept, so I'm going to start by plotting on the y-axis -4. Then from here, my rise over my run is 2/3, which means I rise 2, I run 3. I go up 2, I go right 3. Up 2, right 3. If I go down 2, then to keep it positive, I go left 3. Down 2, left 3. Down 2, left 3. What I would like for you to do next is pause the video and try to graph the next one on your own. Then check it with me. For this next one, our slope is -1/2, which means I am rising -1, I am running 2. My y-intercept on this one is +3. So I'm going to start by putting my first point at 3. Remember, it's on the y-axis, not the x-axis. Then from here, my rise over run means I go down 1, right 2. Down 1, right 2. Down 1, right 2, all the way across. To keep this negative, if I go up 1, I would go left 2. Up 1, left 2, all the way across. One thing you need to remember about slope is that if it's a positive slope, it goes up to the right. If it's a negative slope, it goes down to the right. Be really careful with plotting your slope. Moving on to the next one, I have y equals -3x minus 6. On this one, my slope is -3. My y-intercept is -6. Well, -3 is the same thing as -3/1. So that's how you're going to set up your rise over run. Anytime you have a whole number for your slope, you're going to put it over 1. So for this one, I'm going to start at -6. Remember, on the y-axis. And then to move, I am going down 3, right 1. If I go up 3, then to keep it negative, I go left 1. Up 3, left 1. Up 3, left 1. All the way across. I would pause the video at this point, try the next one, and then we'll check it together. On this graph, my slope is -1/4, so it's set up for rise over run. And then since I'm not adding or subtracting anything to it, that means my y-intercept is 0. So I'm going to start at 0, plot my first point, And then I'm going to move down 1, right, 4. Down 1, right, 4. If I go up 1, then I go left 4 to keep my slope negative. And then I connect my points. All right, the next two are very important, so make sure you pay close attention to these. On the first one, we have y equals 3, and we talked about earlier how if you don't have an x, that means that your x has been canceled out with a 0. So if you think back to the slope lesson, a slope of 0 means that you're going to have a horizontal line. And if I teach you the song, the line of the song is horizontal is our hero. That's because the slope is 0. My y-intercept is positive 3. So here's how you're going to graph your horizontal line. I'm going to start at positive 3 on the y-axis. And an easy way to remember this is y equals 3, and I'm crossing the y-axis at 3. So that tells me that I have a horizontal line going through 3. When your slope is 0, 0, 0, the next one is the opposite. On the next one, I have x equals a number. This is the one that's different from all the others. If you have x equals, then that means that your slope is undefined. And this one actually does not cross the y-axis. So you're probably wondering, how do I graph this? Here's how. Since x equals negative 4, I am actually going to start this time, this is the only time you'll do this, on the x-axis. My x value is negative 4. So if I teach you the slope song, undefined, undefined, that's the slope of a vertical line. I am going to draw a vertical line straight through negative 4. It's really important that you understand the difference between these two lines. Y equals gives you a horizontal line, and x equals gives you a vertical line. An easy way to remember that is y equals crosses the y-axis, x equals crosses the x-axis. Moving on to our next two problems, if you notice, these two problems don't have y by itself. So in order to graph this, you can get y by itself. We learned this back in Unit 2. So in order to get y by itself, I need to move 2x to the other side. We learned last unit that if it's positive 2x, then the opposite is to subtract it over, making this equation y equals 8 minus 2x. For this equation, my y-intercept is 8. My slope is negative 2, which we know is the same thing as negative 2 over 1. So for this line, I am going to start at positive 8 on the y-axis, and then I'm going to move down 2, right 1. Down 2, right 1, all the way across. If I go up 2, then I go left 1 to keep it negative. And we're done. For the next one, if I'm trying to get y by itself, then I need to move over the minus 1/2 x. Well, the opposite of subtracting 1/2 x is to add 1/2 x to the other side. When I do that, I end up with y equals 3 plus 1/2 x. So my y-intercept here is 3. My slope is 1/2. I am going to start with my y-intercept on the y-axis at 3. And then since my slope is 1/2, that's a positive slope, I am going up 1, right 2, up 1, right 2, all the way across. If I go down 1, then I go left 2 to keep my slope positive. So if you're given an equation that doesn't have y by itself, you can get y by itself and then graph it that way. There's actually another way that you can graph if y is not by itself, and that's by using standard form. So we just talked about slope-intercept form, which is y equals mx plus b. If y is not by itself, it also could be in what we call standard form. You saw this formula a little bit in Unit 2. The standard form for an equation of a line is ax plus by equals c. In order to graph with standard form, you also need to know a couple definitions. The first one is x-intercept. X-intercept is where the line crosses the x-axis. In order to cross the x-axis, that means that y has to equal 0. So if I write this as a coordinate, it would be a number with 0 for y. Your y-intercept is very similar. We've talked about this a little bit, talking with b. But your y-intercept is where the line crosses the y-axis. In order to cross the y-axis, x is going to equal 0. So your coordinate will be 0 and then a number for y. We're going to use this to graph lines in standard form. So our first example is 3x plus 2y equals 6. We're going to first find the x-intercept, then we're going to find the y-intercept without getting y by itself. Now, you could get y by itself and graph this line that way. That is one method. So if you prefer that method, you can use that method. But this is another method you can use if you'd rather use intercepts. Since we just talked about how the x-intercept means that y is 0, then what you can do here is you can plug in 0 for y and solve for x. Well, I know that 2 times 0 is going to cancel out. So basically, all I am solving is 3x equals 6. I divide by 3, and I just found that my x-intercept is at 2, 0. Your y-intercept is very similar. For your y-intercept, x has to be 0. So you would do the same thing, except this time you would plug 0 in for x. Since I'm looking for the y-intercept, I'm going to solve for y. Here, 3 times 0 cancels out, and I'm left with 2y equals 6. When I divide both sides by 2, I just found that my y-intercept is at 3, more specifically 0, 3. Now that I know my two intercepts, I can graph both of them on my graph. So I have the point 0, 3, and I have the point 2, 0. Looking at these points, I can see that I go down 3 and right 2. So I can continue that slope all the way across. Down 3, right 2. Down 3, right 2. If I go up 3, then I move left 2 to keep my slope negative. So again, It's important that you know what x-intercept and y-intercept means, but you can also solve this or graph this by getting y by itself. It's really whatever method you prefer. Go ahead and try graphing this line using the x and y intercept method, and then we'll check it. Pause the video, and then we'll go over it together. For my x-intercept, I'm plugging in 0 for y. You basically can just cover up 3y because 3 times 0 cancels out. If negative 4x equals 12, then when I divide by negative 4, x is negative 3. My x-intercept is negative 3, 0. For my y-intercept, I'm going to plug in 0 for x. So I have negative 4 times 0 plus 3y equals 12. Negative 4 times 0 cancels out. And if 3y equals 12, then when I divide by 3, y is 4, meaning that my y-intercept is 0, 4. Now when I plot these 2 points, I have 0, 4, and I have negative 3, 0. Looking carefully at this, I'm going up 4, right 3. I can continue this line, up 4, right 3 with the same slope, or down 4, left 3 to keep it positive, and then I can connect my points. Let's look at this if I had decided to use the method where I get y by itself. If I decided to get y by itself here, then I would start by adding 4x to the other side. 3y is 12 plus 4x. Then to get rid of the 3, I would divide each term by 3. 12 divided by 3 is 4. 4 divided by 3, I'm going to keep as 4 over 3. Using the slope-intercept method, you can see that my y-intercept is 4, which is what we got. I'm crossing the y-axis at 4. And then my slope is 4 over 3. Can't talk. Well, if you notice, that is the same slope that we graphed here. I'm going up 4, right 3. So I wanted to take a second to point out that getting y by itself gives you the exact same line as it did whenever we graphed by intercepts. You can choose the method that you prefer as long as you know what x and y intercepts are. The last thing we're going to do on this video is practice finding x and y intercepts. So I want you to pause the video, try these 3 problems, and then restart it to check. Okay, for number 1, to find my x-intercept, I'm plugging in 0 for y. Basically, the 3y cancels out. If negative 6x equals 12, then when I divide by negative 6, x is negative 2, meaning that my x-intercept is negative 2, 0. For my y-intercept, very similar, except this time I plug in 0 for x. If 3y equals 12, then when I divide by 3, y equals 4, meaning my y-intercept is 0, 4. For number 2, I'm going to do the exact same thing. For my x-intercept, I'm going to plug in 0 for y. If 5x equals negative 10, I'm going to divide both sides by 5, and x is negative 2, meaning my x-intercept is negative 2, 0. For my y-intercept, I'm going to plug in 0 for x. If negative 2y equals negative 10, then when I divide by negative 2, y is 5, meaning my y-intercept is 0, 5. Finally, on the last one, if I plug in 0 for y, then I'm left with negative 3x equals 9. I divide both sides by negative 3, and x is negative 3, meaning my y-intercept is negative 3, 0. For the y-intercept, if I plug in 0 for x, then negative 2y equals 9. I divide by negative 2, and y is negative 9 over 2, meaning my y-intercept is 0, negative 9 halves, or negative 4.5 if you want to write it as a decimal. So again, when you're graphing lines, you can choose either method. You can get y by itself, or you can graph by intercepts, but it's super important that you understand what they are, what your two formulas are, and what your y-intercept and slope are.